Okay, so what we're going to do is from the 6 reactions you did before lunch, well, the 6 experiments you did before lunch, because not all of them reacted, right? Only 3 of them did. Okay, we're going to do those 3 that did, and we're going to show you a way we can identify the products. Okay, so we know that the ones on the top part of your results table reacted, so chlorine and potassium bromide, chlorine and potassium iodide, and bromine and potassium iodide all gave us some sort of change. All right, so we're going to repeat those on a larger scale here, and I'm going to use first of all this solution, this liquid, which is cyclohexane, to show you how it affects the products. Okay, and then I'm going to add in this one here, which is dichloromethane, and we're going to see if we can create a triple layer situation, which will be interesting in its own right. Okay, so we're looking for a start off. We want potassium iodide, so I'm going to put some potassium iodide solution into here. Okay, and now if I react that with chlorine, all right, chlorine water, okay, straight away we get that brown colour of iodine produced. Okay, so if I take potassium iodide again into the second test tube, okay, and this time I react it with bromine water. This is quite weak bromine water, but it's still, nevertheless, you can see the colour. Okay, and if I put some of that in there, again you can see that it's a much darker colour and it's more brown than orange. Well, it's heading towards brown rather than orange, so that means that there's a change occurred. Okay, another one we're going to do is to put potassium bromide in this test tube, okay, which has no colour, and react it with chlorine water. So those are the 3 that you should have got results for, changes. Okay, and all 3 we're getting some sort of colour produced there, aren't we? Or darker colour anyway. Okay, is everyone okay with that? Okay, so what I'm going to do in each of them now is put a little bit of cyclohexane. Okay, so I put some in here. Now cyclohexane forms a layer on the top because it is a non-polar solvent. Okay, it doesn't mix with water. It's lighter, or it's less dense than water, so it forms on the top. Now when I stir this up, hopefully we'll be able to see the colour go into the top layer, so we can see a nice, yeah, you can see it there now. See that nice purple colour? Okay, so if I do that to all 3, we might be able to see a difference in the colours. Okay, so that one and that one. Okay, so I'll use a different stirring rod for each one, because otherwise it might contaminate our results. What I'm trying to achieve here is to get the product, which is the coloured substance, to come out of the bottom layer and dissolve into the top layer. Okay, and you can see that it's developing that purple colour. Okay, it's not as bright as the left-hand one because it's not as concentrated, is it? The original colour wasn't as intense. Okay, so that's going okay there. Now I can get it to go a little bit better by taking it out and shaking it up with my hands, which I won't do right at the moment. And this one here, we've got that sort of orangey colour in the bottom. And again, you can see that the colour is moving more into the top layer. But this time it's not going purple, is it? Okay, this time it's going to an orange colour. And that is the difference between the halogens that we've managed to produce, is that these 2, okay, all 3 had a darkish colour, right? So really, given the colours of these don't vary very much, you couldn't really tell what it was that you'd produced. Okay. However, this purple colour here and here, all right, is a positive test to show that iodine, I2, has been produced. Okay, because iodine has a purple colour in organic solvents, such as cyclohexane. Okay, but bromine does not; it remains its orange colour. However, in all 3 cases, the iodine or bromine is more soluble in the non-polar organic layer on the top. Okay, so the other solvent I've got, or the other solution liquid I've got here actually, is dichloromethane. I'm going to put a bit of that in each one. And with a bit of luck, that'll go to the bottom because it's more dense than water. And then we should set up a situation where we've got 3 layers. A bit of luck. Okay, so I stir it up again. And the middle one. And this one over here. Didn't do exactly as I wanted. I think what it's done. Oh, I can certainly see 3 layers in the middle one, can't you? All right. This one over here. Hard to say. It looks like there's another layer in the top there, and there's certainly another layer there. So we're settling out to 3 layers. So what we've got now is we've got the bottom layer, which is one of the organic solvents. Now that one is more dense than water. Then we've got the middle layer, that's the water layer. Then we've got the top layer, that's the cyclohexane layer, because cyclohexane is less dense than water. So you end up with 3 layers. And the layers don't mix because the top and bottom layers are non-polar, and the middle layer water is polar. Okay? So that's some reactions of halide ions with halogen molecules. The other combinations that you tried, they don't react, and we'll talk about why that is later.